All right, beautiful people. So today we're talking about equivalent expressions and how we create them. So the thing about equivalent expressions is that whether you remember them or not, you have been writing them all your life. So let's start by writing down what does it mean to be an equivalent expression. Okay, so this breaks down into two different words, the word equivalent and the word expression. Now, you've heard equivalent before. You're going to notice that equivalent has the very same beginning as the word equal. So equivalent means equal. And an equivalent expression is an expression whose value is always the same as the original. So in fact, I'm going to add in always because I didn't write that. Always. Okay, and what I mean by always is I could plug any variable number n and I will always get the same answer. So here are some examples. I'll start with numerical expressions. So 2 plus 5, which we know equals 7, is equivalent to 5 plus 2. Now notice I used the equal sign to denote that something is equivalent to something else. So you've only used the equal sign so far to give the answer, but an equal sign can also represent that two sides are exactly the same. So I'm going to write equivalent because it means equal to. Because 2 plus 5 is 7, and 5 plus 2 is 7. Okay, so here's another example. How about 15 times 3 is the same as 3 times 15. So again, the idea here is the same, because 15 times 3 is 45, and 3 times 15 is also 45. So again, we've got equivalent. Okay. Now, if I have a variable, I could also write like a similar thing. Like I could say 7 times x is the same as x times 7. Because no matter what I put in for that x, it'll always be the same. If x is 2, 7 times 2 is the same as 2 times 7. If x is 3, 7 times 3 is the same as 3 times 7. Since x will remain the same in both sides, they're equivalent. So again, I've got equivalent. Okay. So what we're going to do today is just talk about some of the properties that give us equivalent expressions. So let's start with commutative property. So commutative property. Now, like I said before, these are all properties that you have used before. You just didn't know the name of them. So commutative property goes like this. Changing the order in an addition or multiplication problem creates equivalent expressions. So here are some examples. So we'll start with addition problems. If I have 17 plus 11, I can change the order so that 11 comes first plus 17. Okay, they're both equal because they're both going to equal 28. So I know that they're equivalent. Okay. Likewise, if I have variables, I could do a plus b equals b plus a, because no matter what I plug in for a and b, as long as it's the same on both sides, I'll still get the same equation. I'm going to have them equal or equivalent. Okay, so that's it for addition. For multiplication, it's very similar. So if I did 3 times 4, it's going to be the same as 4 times 3 because they're both 12, right? So again, I've got equivalent expressions. And likewise, if I did variables, I could do x times y is the same as y times x for whatever I plug in for x and y. Equivalent. Okay. Doesn't matter what I plug in as long as it's the same on both sides of that equal sign. All right, so that's commutative property. That's where we switch them around and it becomes the same. Okay, this word commutative is like the word to commute. When you or your adults commute to work, they're driving to work or they are switching places, which is why it's called commutative, because the two numbers are switching places. Okay, we're going to do associative next.